In the previous lecture, I discussed that what are the uses as well as what are the limitations of Routh stability criteria. Okay. See, if the characteristic equation, you saw that Routh stability criteria is based on characteristic equation, right? If you want to check whether a system is stable or not, right? So, write the closed loop transfer function, use the equation denominator of the closed loop transfer function equal to 0 for making the characteristic equation. And if it is a standard feedback control system, then the denominator is always 1 plus open loop transfer function that can be used. And then I told you various cases of Routh stability criteria. You can use that and then check whether a system is stable or not. Now, based on Routh stability criteria, we have the category of questions. So, before starting the next topic, I will first discuss this category of question, because in the last lecture, I was not able to discuss this in detail. So, category of questions on Routh and how you have to attempt them, that is also important, because there many students make mistakes here. आपको table बनानी तो आती है, but then you may make mistake while marking the correct option, and because now MSQs are there, so you have to be very careful which option is correct, which option is not correct, है ना? There should be no confusion here. So, category of question on Routh criteria. First of all, you must know what was the limitation, that if dead time is there, then Routh stability criteria is not applicable. Actually, this was not the limitation. The limitation was that the characteristic equation must be polynomial. Now, if your system contains an element whose transfer function is causing the characteristic equation to not to be a polynomial, in that case, it is not applicable. Now, dead time was one of this transfer function. You saw that the pure dead time has the transfer function of e raised to the power minus tau ds. बताया था कैसे आएगा? What is the role of pure dead time? It only translates the input by a time tau d. Tau d time से input को delay कर देगा, output को delay करेगा. Actually, input को shift कर देगा. It will not change the nature of input signal. So, dead time was one example. Suppose you get some other kind of system which is also causing the characteristic equation to not be a polynomial, then also this Routh stability criteria won't be applicable. Okay? So, what are the category of questions on Routh stability criteria? First of all, first category, category 1. This one is, suppose all the values are given. All the values means all the values are known. It means all the parameters are known, whether it is Kc, if it is tau I, then tau I, all those things are known. All the values will be given to you. What they are going to ask? They are going to ask category A. Category A. Whether, okay, not category A. In this case, there will be only one subcategory. They are going to ask whether the system is stable or not. Is stable or not. Stable or unstable or critically stable. I mean, they will give you Kc and ask about stability. I discussed this in the last lecture कि इस तरह का एक category हो सकती है, इस तरह की एक category है ना. Whether the system is stable or unstable or critically stable. It is possible. You can have one category of this type. Correct? Okay. So, Kc will be known, tau I will be known, tau d will be known, whatever parameters are there, all the values will be known, and the question will be regarding whether the system is stable or not. How to solve this? I gave you the criteria for checking the stability. First of all, write the correct characteristic equation, arrange them in decreasing power of s, check whether the A naught means the first coefficient is positive or not. If yes, then fine. If not, make it positive. After that, check if there is any negative sign in the characteristic equation. If yes, means the system is unstable, definitely unstable. After that, if you want to make Routh array to know how many roots are positive, you can do that. If all the coefficients are positive, then you have to make Routh array and then use the Routh test. What was the test for stable, unstable and critically stable? I gave you. That is one category of question. Second category. Second category is, okay, values are known and they are asking you about stability. Okay, stability is known. Stability is known. Stability is known means it is known whether the system is stable or unstable or critically stable. It is known. Okay, stability is known. Find Kc. Find Kc. Right? For what value of Kc? Now there can be subcategories. That for what Kc system is stable. For what value of Kc the system is stable. Whenever you say that for what value of Kc the system is stable, actually it is not a value, it will be a range. Kyunki what is the criteria for stability? I am taking the reference of the first Routh table that we made. I think it was A0, then A2 and then A4, and then it was A1, A3 and A5. This was the I think the elements in the first two columns of the Routh array, and then we were having B1, B2, C1, C2, D1 and E1. So I am taking reference of that table. आप चाहो तो फिर से बना लेना. For what value of Kc the system is stable? So what should be the condition? The condition should be A0 should be greater than 0. This was already greater than 0, right? In the starting only. Still I am writing this condition, right? What next? A1 should be greater than 0. This was the first column of the first element of the second row. B1 should be greater than 0, right? C1 should be greater than 0. D1 should be greater than 0. All of them must be 0 and E1 should be greater than 0, right? This is the criteria for finding value of Kc. अब देखो होता क्या है that normally when you solve these kind of questions, normally see these are already greater than 0. Why? Because I told you the criteria that when you are going to make the Routh table, उससे पहले ही आप देखोगे, you will make the Routh table only when you have a doubt. You will make the Routh table only when you have a doubt. Okay, you have a doubt whether the coefficients are, whether the system is stable or unstable, because all the coefficients are positive. Also, you will find that most of the times B1 and C1 will be positive, right? What happens that generally we find the value of Kc with these two inequalities. With these two, इसको लिखो मत है ना, इसको लिखो मत. With these two inequalities. Okay. Now with these two, these are inequalities. So when you solve for inequalities, you will get a range for Kc, not the value of Kc. Okay. And generally, we find the value of Kc from D1 and E1, right? And you will see that D1 greater than 0 is giving you an answer. E1 greater than 0 is also giving you an answer. Fine. D1 greater than 0 is also giving you an answer for Kc, and E1 greater than 0 is also giving you an answer for Kc. Please note that these two answers will never be contradictory. ऐसा नहीं होगा that D1 greater than 0 is giving you that Kc should be greater than 3 and E1 greater than 0 is giving you Kc should be less than 3. ऐसे range नहीं मिलेगी, है ना? But in GATE exam you will find that most of the correct options are according to D1 greater than 0, not according to E1 greater than 0. Are you getting this? देखो होता क्या है? Let me make that table again so that I can use that reference. Of course, it's not like every time the Routh table will consist of only this much of elements. There can be more elements or less element. Okay, I told you that this E1 and A5 are same and C2 also, they are same, right? A5 was positive, so C2 is also positive, so E1 is also positive. Take. So normally, when we have to find that for what value of Kc the system is stable, it is generally found with this. D1 greater than 0, not from the last element. Generally, the last element of the first row, the inequality of that element is not used. ध्यान से सुनना, confusion नहीं create करनी है. देखो, मैं ये इसलिए बता रहा हूं, फिर आप वापस नहीं तो फोन करोगे कि सर आपने बताया था कि ये ऐसे ऐसे होता है, यहाँ पे ऐसा आंसर दिया है. ठीक है, तो आपको सारी बातें मालूम होनी चाहिए. देखो, for what value of Kc the system is stable? This is the question. Okay. Now, for stability, the criteria was all the element of the first column of Routh array must be positive. Of course, this is the criteria, and all of them must be positive. But the last element E1 is already positive. Why? Because it is same as C2, which is same as A5. So no need to use that inequality for reporting the final answer. So normally, what we say that the last element गलत नहीं है वो. और ऐसा भी नहीं कि सर लास्ट एलिमेंट नेगेटिव होगा तो चलेगा क्या, नहीं, द सिस्टम विल बिकम अनस्टेबल. तो यूजुअली द लास्ट एलिमेंट which can be even if if it is a fifth degree equation, it can be d1 also if it is a less degree equation. Usually the last element inequality is not used for reporting this answer, is not used for reporting the answer. मैं questions लूंगा तो आपको clear हो जाएगा, but फिर भी मैं अभी से ये बता दे रहा हूं, for reporting the answer. I'm not saying that the last element can be negative. Please keep this in mind. ऐसा नहीं कि ये क्वेश्चन फिर वापस आप पूछो कि सर आपने कहा था कि even तो कुछ भी हो चलेगा, ऐसा नहीं है. Even must be positive. But you know that even greater than 0 is going to give you a range for this Kc, and d1 greater than 0 is also going to give you a range. आप कौन सा आंसर रिपोर्ट करोगे? Of course they are not contradictory. They will give you a range of Kc and that is the correct answer. But I am talking with respect to GATE exam. In GATE, what happens that normally you don't get your answer if you use even greater than 0. So don't use that inequality. वो गलत नहीं है पर use नहीं करना, right? Depends upon the option again. But normally what happens so far, what has happened that d1 greater than 0 is giving you the answer. I mean the second last element, not always d1, the second last element. ठीक है? One more thing. For what Kc the system is stable, here you will get a range of Kc. Here we will get range of Kc. Here we will get range of Kc. कहां से मिलेगा ये range? Range of Kc, and how you are going to find this range? By writing d1 greater than 0. यहां से मिल जाएगा. Not always d1, the second last element. मैं इस टेबल का रेफरेंस ले रहा हूं, मैं बार बार बता रहा हूं. मुझे पता है फिर वापस मेरे पास घूम के वही सवाल आएगा. ठीक है. बी, फॉर व्हाट Kc द सिस्टम इज अनस्टेबल. फॉर व्हाट Kc द सिस्टम इज अनस्टेबल. हाउ यू आर गोइंग टू रिपोर्ट दिस आंसर? अनस्टेबल d1 less than 0. You'll get your answer. And of course here also you'll get some range. For what Kc the system is critically stable. For what Kc the system is critically stable. This can be the question. Then how to find critically stable means neither stable nor unstable, so it can be d1 equal to 0. These are the type of question. I mean Kc can be stability condition can be given to you and then they are going to ask you that what is the value of Kc. So when you solve this inequality you will get range of Kc. When you solve this inequality you will get range of Kc. When you will solve this equality you will get range of you will get value of Kc in this case. Okay, third case. Third case can be Kc is given, okay, and number of positive poles are asked. Of course, I mean, see, if Kc is given, everything is given, and they are asking you how many positive poles are there. The system is definitely unstable. Number of positive poles are asked. How you are going to find? Consider the first column. A1, sorry, this was A0, A1, B1, C1, D. अब बोलोगे सर आपने, कई बार बच्चे आ जाते हैं कि सर आपने तो मना किया था E1 से नहीं करना है. E1 से ये नहीं करना है, ये करना है. यहाँ पे आपको साइन तो चेंज करना पड़ेगा, साइन चेंज देखना पड़ेगा. You check the sign changes of all these elements, how many times the sign is changing, including this sign change. Don't miss this. Okay. ये कुछ लोग confusion create करवा देते हैं, बोलते हैं कि E1 किसी काम का नहीं. E1 has to be more than 0. It's not like E1 is less than 0 and still the system is stable. No, E1 has to be more than 0. But the thing is, the range of Kc which you are getting by substituting E1 greater than 0 is normally not there in the options. That is the only thing. Option में नहीं है. That's why I'm telling you that you'll get your answer normally from d1 greater than 0. Fine? Okay. In this case, you have to count the sign changes. So, number of sign changes. And then you can report your answer. That this much number of roots are positive. These are the categories of question based on Routh array. क्योंकि देखो, when the question says for what Kc the system is stable, many times when I ask this question, बच्चे क्या करते हैं? They give me a value. I'm not asking you, you should not get a value. If I'm asking you about stability, you should get a range. If I'm asking you instability, that for what value of Kc the system will become unstable, you should get a range. Fine. If I'm asking you critically stable, then only you should get a value. तो कब वैल्यू मिलेगी, कब रेंज मिलेगी, ये पता तो होना चाहिए ना. अदरवाइज सपोज इन MSQ काइंड ऑफ क्वेश्चन वी हैव KC लेस देन 3 एंड KC इक्वल टू 3, विच ऑप्शन यू विल करेक्ट, यू विल टिक, है ना. तो डिपेंड्स, यू शुड हैव अ क्लियर आइडिया सर वेदर I should get a range of KC or I should get a value of KC. If they are asking you about stability condition, whether for what value of KC the system will be stable, then you should get a range, of course, not one value. You should get a range. Fine. Range मिलनी चाहिए, एक ही वैल्यू नहीं मिलेगी. ठीक है. Okay, so these are the categories of question on Routh array. Of course, we will practice question. आप चाहे तो, खैर मैंने आपको सारी बातें बता दी, आप चाहो तो अभी भी प्रैक्टिस कर सकते हो. मैं एक ही साथ स्टेबिलिटी के क्वेश्चंस प्रैक्टिस करूंगा, राउथ पे अकेले सिर्फ प्रैक्टिस नहीं करेंगे. एंड आई ऑल्सो गिव यू one thought problem in the previous class that try to find out how many number of roots were there. Okay, so I'll answer that question in some lecture. So first of all, note it down, and so that we can proceed to the next topic. We are still doing the stability analysis, and I told you one method of stability analysis, which was Routh stability criteria. But what we found that Routh stability criteria is limited to only those systems in which the characteristic equation is polynomial. Now the thing is, we saw that when that time is there, the characteristic equation is non-polynomial. Fine. And if the characteristic equation is non-polynomial, Routh stability criteria cannot be used. The problem is that dead time is everywhere. Okay, so it seems that Routh stability criteria should not be used. Okay, so whatever be the case, but we know that theoretically at least I cannot use Routh stability criteria when there is dead time present in the system. If you are getting a question on control system, there is a control block diagram and dead time is also there. Never use Routh stability criteria. Even question has mentioned or not, don't go for Routh stability criteria. So we have another chapter in stability analysis only. In stability analysis, we first discussed that what is stability. In stability analysis, we then discussed that Routh test, one method of stability, but it has some limitation. In stability analysis, now another chapter is frequency. आप इसको टॉपिक कह लीजिए, चैप्टर कह लीजिए, वो चैप्टर कह लो, ये टॉपिक कह लो, डजंट मैटर. फ्रीक्वेंसी रिस्पॉन्स एनालिसिस. फ्रीक्वेंसी रिस्पॉन्स एनालिसिस. ठीक है, दैट इज अनदर चैप्टर, फ्रीक्वेंसी रिस्पॉन्स एनालिसिस. नाउ हाउ इट इज गोइंग टू remove that disadvantage, the limitation which is associated with the Routh stability criteria. Let us see कैसे remove करेगा. ठीक है, तो first of all we must know what is the meaning of frequency response. Frequency means, frequency term is generally associated with the sinusoidal curves, है ना, waves के साथ ही associated होता है ना frequency. We don't talk about frequency when the function is a step function or when the function is a ramp function, right? We talk about frequency when the function is kind of sinusoidal, cos function, sine function, wave function, wave kind of thing is there. Okay, oscillations are there. Okay, so it means this chapter is going to deal with, this topic is going to deal with oscillatory things. Okay, so first of all, what is the meaning of frequency response? It means, see, response is also there. Response means output and analysis. Frequency का मतलब oscillations, response means output and analysis. Okay, so it means analysis of the response which is sinusoidal. That is the meaning of frequency response. It means analysis of the response which is sinusoidal. First of all, you must know कि इस चैप्टर को क्यों बोला जाता है, इस टॉपिक को क्यों बोला जाता है फ्रीक्वेंसी रिस्पॉन्स एनालिसिस. यहाँ पे हम ऐसे रिस्पॉन्स की एनालिसिस करेंगे जो साइनसोइडल होगा, बिकॉज साइनसोइडल रिस्पॉन्सेस ओनली हैव सम frequency of oscillations. So we are going to analyze the oscillatory responses here. Got it? Okay. So ठीक है, अब मुझे ये बताओ, if response is sinusoidal, can I say that input is always sinusoidal? Yes or no? The response, the output is sinusoidal. Can I say that input is also sinusoidal? 100%. Yes or no? No. You have seen that in the case of the second order system, which was underdamped, the input was step and still I was getting sinusoidal output. I was getting, right? That is the things. Write down that we can get oscillatory response वी कैन गेट ऑसिलेटरी रिस्पॉन्स। मैंने आपको शुरू से बोला है कि ध्यान रखना, ये जो चैप्टर्स हैं स्टेबिलिटी एनालिसिस के, ये गेट के हिसाब से, गेट पॉइंट ऑफ व्यू से, इवन कंट्रोल का, ये यही तो मतलब स्टेबिलिटी वाला जो पार्ट है, दिस इज द मोस्ट इंपॉर्टेंट थिंग। तो क्वेश्चन आ सकता है राउथ से, क्वेश्चन फ्रीक्वेंसी रिस्पॉन्स से, बोर्ड स्टेबिलिटी क्राइटेरिया, एम्पलीट्यूड रेशियो, गेन मार्जिन, फेज मार्जिन, एंड दीज आर द कॉन्सेप्ट्स वेयर इवन द स्टूडेंट्स हैव सम डिफिकल्टीज, लिटिल थोड़ी कहीं ना कहीं clarity issues are there, difficulties are there, so you have to focus on these concepts only. And that is why I'm saying, suppose you kept focusing on how to reduce the block diagram और ये सारी चीजें भूल गए, है ना। ब्लॉक डायग्राम रिडक्शन आनी चाहिए, है ना, and you must practice 3, 4, 5 block diagrams, 10 block diagrams. Suppose I gave you, I think, 3 block diagrams in classroom itself, and none of them was from GATE. 2 block diagram questions, which is a kind of different kind of block diagram, are in GATE. So 3 plus 2 makes it 5. 5 block diagrams. Apart from that, if you want, you can practice 5 more. That's it. Now, whether you were able to solve those block diagram in the first attempt or not, leave it. है ना? Next topic, that is. तो मैं देखो, ये मेंटालिटी डेवलप करना सीखो, छोड़ना सीखो चीजों को, है ना, छोड़ना सीखो. There is nothing wrong in leaving the things behind, leaving the concepts behind and moving ahead. There's nothing wrong here. You can't stay at a single concept for the entire month, for the entire day. Each and every concept is important. You have to go through each and every concept. ऐसा नहीं है that you are stuck on a single, because this then becomes your habit, and this habit is observed in the GATE exam also. You're stuck on a single problem. Why I'm not able to solve this? Why I'm not able to solve it? This becomes your attitude. You are stuck on one problem. God has given you 65 opportunities in GATE exam. Why to stuck on one problem? Right? 65 opportunities. 65 सवाल मिलेंगे. Why to stuck on single problem? Yeah? So, and see, this happens even if you don't want to, even if you know that, okay, I am not going to stuck on single problem, still this is going to happen, because it is your inherent characteristics. It is your nature. It is your nature that you get emotionally attached. You get emotional when you are not able to solve a particular problem and you have read the topic. So, ये attitude ही बदलना है ना? ये attitude ही बदलना है ना? Go through new topics. Go through new topics. I mean, you have given some time to block diagrams. Now leave it. Okay. देख लेंगे, है ना, ऐसा देख लेंगे इसको. Okay. You know the concept. You have done a little bit practice. Then देख लेंगे. निपटाओ, पीछे निपटाओ, कोई दिक्कत नहीं है. यार एक चीज समझो, आप अभी कितनी भी मेहनत कर लो, during some later months, अभी suppose this is August, right? Later months means during November, during December, फिर से पढ़ना तो है ही, है ना. और सपोज इफ यू आर डीलिंग द कोर्स बाय, आई मीन यू आर वेस्टिंग द एंटायर डे ऑन 1 or 2 टॉपिक्स, तो आपका वो जो सेकंड टाइम साइकिल आएगा वो काफी देर बाद आएगा, एंड वी वांट थर्ड साइकिल ऑल्सो, फोर्थ साइकिल ऑल्सो. सो जल्दी निपटाओ, है ना. आपको जो टॉपिक्स मिल रहे हैं उसको जल्दी खत्म करो, पढ़ो, प्रैक्टिस करो, ध्यान से लिखो, देखो, क्वेश्चन बनाओ, खत्म, है ना. डोंट वेट फॉर समवन टू टेल यू कि हाँ भाई तुम्हें याद हो गया, चलो आगे बढ़ो. नोबडी विल कम टू टेल यू. यू विल हैव टू टेल योरसेल्फ दैट सर, और व्हाटएवर इज योर नेम, ओके, कि आई हैव डन इट, ओके, लेट्स मूव ऑन, है ना. तो आपका जो हो गया, आगे से मूव ऑन करना सीखो. इफ यू डेवलप दिस एटीट्यूड, देन ओनली इट विल बी रिफ्लेक्टेड इन योर एग्जाम्स. फाइन. ये एटीट्यूड में होना चाहिए, ये अपने आप एग्जाम में. डोंट से कि सर उस 3 घंटे के लिए आई विल बिकम अ डिफरेंट पर्सन, आई विल बिकम अ डिफरेंट पर्सनालिटी फॉर दोज 3 hours. दिस नेवर हैपेंस. आप सोच के बहुत कुछ जाते हो, अल्टीमेटली बिकॉज आपके पास उतना सोचने का फुर्सत ही नहीं रहती यार. यू विल नॉट बिकम अ डिफरेंट पर्सन इन द एग्जाम, यू विल रिमेन द सेम पर्सन विच यू वेर थ्रू आउट द ईयर. सो ट्राई टू बिकम डिफरेंट पर्सन फ्रॉम नाउ ओनली, है ना. यू हैव टू बिकम डिफरेंट पर्सन फ्रॉम नाउ ओनली. डेवलप attitude of writing the exam. Intelligent, this I always say this line from the past 4 years, I am always saying this line: intelligent person never cracks the exam, never get a single digit rank, only the smart person get the single digit rank. Intelligence is fine, but it is not sufficient for getting you single digit rank. Smartness, this exam attitude, it's all about exam. एग्जाम हैज चेंज्ड अ लॉट फ्रॉम द पास्ट. भाई पहले के गेट के पेपर देखे आपने? हैव यू सीन द 90s पेपर and see the recent papers, see 18, 19, 20, whatever recent papers you want to see. Have you seen the difference? Things have changed a lot. Now it's not only about whether you know or not. It's about your attitude in the exam. है ना? सिर्फ ये नहीं कि मुझे आता है सर, ये नहीं, ये भी कि सर अगर ये क्वेश्चन मुझे नहीं हुआ तो कोई बात नहीं, इससे मेरा क्या कोई रिश्तेदार थोड़ी लगा, मैं तो अगले पे जाऊंगा, कोई दिक्कत नहीं. मुझे उसने नंबर नहीं दिए तो ये नहीं देगा तो वो देगा, है ना? इफ यू आर इमोशनली अटैच्ड, you're finished, है ना? So don't get emotionally attached with things, at least not in the questions, in the exams, है ना? That is very very important. Huh? That is why I say when you are attempting the exam in the very first cycle, in the exams also there are cycle, in the revisions also there are cycle, everything is cycle. Revisions, course, there are cycles, ठीक है? Or the number of cycles you can maintain in this revision also, that is good, है ना? सो देखो आपको ना ये सारा कोर्स जो आप पढ़ रहे हो ये आपको 2 बार 3 बार 4 बार पढ़ना तो वैसे ही है, 4 बार भी पढ़ना है ना? इफ टाइम अलाउज 4 बार भी पढ़ना है, ठीक है? ओके, लेट्स कंटिन्यू हियर. वी कैन गेट ऑसिलेटरी रिस्पॉन्स. इट मीन्स द एनालिसिस ऑफ द रिस्पॉन्स विच इज ऑसिलेटरी, विच इज साइनसोइडल, है ना? साइनसोइडल ऑसिलेटरी. वी कैन गेट ऑसिलेटरी रिस्पॉन्स even if the input is non-oscillatory. An example, the input is non-oscillatory. Example, step input of second order underdamped system. For example, step input of second order underdamped system. Second order underdamped system. We have seen, no need, I don't need to comment anything else here. I was giving step input and the response was the system was underdamped and the response was oscillatory. So I can have oscillatory response when the input is non-oscillatory. Also, I can have oscillatory response when the input is oscillatory. Do you remember the response of first order system for sinusoidal input? Was it oscillatory? Yes. I can also have, we can also get oscillatory response. We can also get oscillatory response if the input is oscillatory. मतलब देखो, input is oscillatory. What I want to convey that if the input is oscillatory, the response will be oscillatory. 100%, always, right? We can also get oscillatory response if the input is oscillatory, always. If input is oscillatory, you'll always get this oscillatory response. If input is non-oscillatory, you may get oscillatory response, like in this case. So, okay, the chapter says that I have to deal with the response which is oscillatory. Now, this is also. But in this chapter, I will only deal with those cases where both input and output are oscillatory. If input is oscillatory, obviously output is oscillatory. So, I should say that in this chapter, I will deal with those cases where the input is oscillatory. Clear? Okay. So in frequency response analysis, in this frequency response analysis, we will deal means this is a chapter which is specially dedicated to sinusoidal inputs. We will deal with sinusoidal input. And of course, if the input is sinusoidal, output is always sinusoidal. In this chapter, we will deal with sinusoidal inputs for various systems and response of and its output, of course, which will be sinusoidal. Sinusoidal input. Actually, मुझे तो output को study करना है, input को थोड़ी study करना है, and its response for various system. हमने system fix नहीं किया. System can be first, second, pure capacity, pure dead time, third order. Any system can be there, but the input will be 100% oscillatory, and if input is oscillatory, then 100% the response will be oscillatory. In this frequency response analysis, we will deal with sinusoidal inputs and its response. And its response, what else? For various systems. For ये लिख देता हूँ various system because otherwise आपसे कभी कभी ऐसा मैं पूछता हूँ कि हम फ्रीक्वेंसी रिस्पॉन्स एनालिसिस में क्या पढ़ते हैं, आप कहते हो सर साइनसोइडल इनपुट टू फर्स्ट ऑर्डर, फर्स्ट ऑर्डर नहीं, साइनसोइडल इनपुट, साइनसोइडल इनपुट, साइनसोइडल आउटपुट for various system. That is the part that we discuss here in frequency response analysis. I will not discuss this case here where input is not sinusoidal. Please remember, if input is sinusoidal, see, बार बार बोलने के बजाय लिख ही दो, है ना, any system if xt is sinusoidal, and see, in frequency response analysis, sinusoidal is fixed that our xt will be a sine omega t. If this is your xt, any system can be there, yt has to be sinusoidal. And this study of the response yt for sinusoidal input to any system is frequency response analysis. So that is about the name. Okay. Now the question arises ki sir, okay, I know that response is going to be there, but theek hai, what we are going to study in this response? Do you remember that for a first order system, when we discuss the first order system in frequency response analysis, I'm writing short always, we will analyze two parameters. We will analyze two parameters. Two parameters of the response. Two parameters of the response. Okay? In frequency response analysis, we will analyze two parameters of the response. Do you remember when we discussed the first order system and sinusoidal input? We derived that the output was also sinusoidal after neglecting that initial changes after a long time actually, when the exponential term contribution was becoming 0, right? So there we found two things. One was phi, which I told you that is called phase angle, and the other was the amplitude ratio. If you don't remember, what two parameters we are going to analyze here? The one is called amplitude ratio. So for any system, देखो क्या क्या करते रहेंगे हम लोग, सिस्टम बदलते रहेंगे, इनपुट बदलना है क्या, input is fixed for different system. I'll keep on changing the systems. We will find amplitude ratio, which in short I'll write as AR, and we will find phase angle, which in short I will write as phi. तो करना क्या इस चैप्टर में, we have to take different systems, right? And to all those systems, I will give sinusoidal input. After giving sinusoidal input, the response will be there. And from that response, I will calculate amplitude ratio and phi. Now, please try to recall that when we discussed the first order system and I found this amplitude ratio and phi, it took some time, right? It took time for the first order system to write the response in the form of r sine omega t plus phi, right? Now, there was some mathematical manipulations, trigonometric identities I used. So suppose that was a first order system and still it was complex to take Laplace inverse and all. Suppose it becomes a second order system, the method will further become complex, right? And it will take more time. Ultimately, I want these two things. But finding these two parameters, this is the next point. Finding these two parameters from basic method. What is called basic method? Basic method का मतलब, basic method is taking Laplace inverse of y bar s. अब y bar s का Laplace inverse लेके then you find yt, and even after that you have to do some mathematical manipulations. Then only you will find AR and phi. So finding these two parameters from basic methods is lengthy, is time consuming. So in this chapter, I'm giving you one more method which is less time consuming, and ultimately it is giving me this. ठीक है, तो ultimately जो चाहिए वो मिल रहा है. So I'm going to take less time if I'm using the second method. Finding these two parameters from basic method by taking Laplace inverse of ys is time consuming. So we will use an alternate method. Okay. Now, what is that alternate method? Is it a shortcut? Yes, it is a shortcut. But is it valid everywhere? It is valid everywhere. Okay. What is that alternate method? So this is we will be using everywhere. ऑफ कोर्स आप बेसिक मेथड से कर सकते हो, बट इट इज वेरी टाइम कंज्यूमिंग. सपोज अगर मैंने सेकंड ऑर्डर सिस्टम दे दिया, आप बेसिक मेथड से करते रह जाओगे, इट विल टेक अ लॉट ऑफ टाइम. ओके, राइट. सो ओके, व्हाट इज द मेथड फॉर फाइंडिंग AR and phi? डोंट थिंक दैट इट इज अ न्यू काइंड ऑफ थिंग. AR and phi आपको पहले से भी मिल जाएंगे, जैसे पहले फाइंड किए थे फॉर द फर्स्ट ऑर्डर सिस्टम, द वे वी फाउंड AR and phi, same method can be used, but I am going to give you less time consuming method, and I'm going to write these things step by step, so note it down. First of all, first step, what is the system? System can be AR and phi. See, AR and phi, first of all you find for individual system, so write GS. Now you may ask, sir, GS of what? GS of the system for which you are finding the amplitude ratio and phi. Normally we find amplitude ratio and phi not for the overall system. Overall system के लिए find करेंगे, but ऐसे नहीं. We find AR and phi for the individual components. So I'm writing here, write G open S. Open S means write G open. Don't say, sir, open means open loop transfer function. No. Write G open S means, suppose GC. What is GC? GC can be written as GC open, means controller open transfer function, means it is the controller transfer function. Sometimes GP can be written as GP open. I'm not writing open loop transfer function. GC open, GP open. Okay, same thing, right? GC open means the controller transfer function. If the controller is P controller, then it is KC. GP open means the process transfer function. If it is a first order transfer function, then KP by tau PS plus 1. What else? Suppose I write GV. GV can also be written as GV open. Valve. Suppose valve is second order transfer function, then what is GV open? These are just examples. Don't learn them कि ये हमेशा ही होता है. No, just examples. Twice of tau PS plus 1. GV open and so on. Right? So first of all, write G open S. Right? So you may ask, sir, then how I'm going to find the AR and phi for the control system? I'll give you the methods, don't worry. Okay, second point. Second step, put S is equal to, of course, these transfer function will be function of S. Put S is equal to iota omega, where? In GS, and write G of iota omega. Put S is equal to iota omega and write G of iota omega. I mean, in GS, whatever this open transfer function you have written, put S is equal to iota omega. Okay? Once you put S is equal to iota omega, now what is the next step? And write, इसी में लिख लेते हैं, and write G of iota omega in the standard form of a complex number. In the standard form of a complex number. Now, complex number, small basic knowledge of complex number is required. However, I know where you are going to find difficulty. I'll explain that. Put S is equal to iota omega and write G of iota omega and write G of iota omega in the standard form. What is standard form? G of iota omega is equal to the real part plus iota into imaginary part. इस तरह से पहले लिख लेना. G iota omega is equal to this. Now, for a complex number, you might have studied about calculation of two things. One is called the modulus of complex number, and one is called the argument of complex number. So, when you write this equation, when you write this expression G iota omega in the standard form of a complex number, now we have to calculate two things. Third step, calculate modulus. What is modulus? Calculate. We show the modulus by this. Modulus of G of iota omega. Do you know how to calculate modulus of a complex number? That is square root of real part plus square of imaginary part. Okay, that is how you calculate G iota omega. Then in the third step only, please write, I'm erasing this part. And the third step only, this is going to make the calculation very easy and short as well. Okay. Calculate G iota omega, and in the third step only we have to calculate argument also. Argument of complex number. Now the question is how you find the argument of a complex number. I know most of you have difficulty in finding the argument of a complex number. So उसको यहाँ पे बता देते हैं. अब ये मत कहना कि सर कॉम्प्लेक्स नंबर नहीं पढ़ाया, है ना, ये चीजें पढ़ाने की नहीं है, ये आपको यहीं पे सीखनी है ना, तो जब पढ़ाएंगे तब पढ़ाएंगे. Meanwhile, you learn these things here only. Calculate modulus of g at omega, root of real part square and imaginary part square. I'm continuing from this point. Also, in the third point only, you can write also calculate augment. Augment is generally written as ARG. Augment of what? Augment of g of at omega, because this is a complex number. Augment can be calculated for any complex number. See what happens that suppose I'm denoting augment by phi or something like that. Phi का use कर लेते हैं. Let's say that augment is phi. हाँ? So phi is augment of g iota omega, that is phi. But phi is phase shift also, na? So I can't use phase shift. Sorry. Let us not use the phi. No, it is fine. It's fine. It's fine. It's fine. Okay. Let me write here. Here first write that the amplitude ratio. You wanted to find amplitude ratio, right? Amplitude ratio will be equal to the same modulus. What we did, write the g iota omega in the standard form of a complex number and find modulus. The modulus you found is same as the amplitude ratio and your part is done. Now I have to find augment, and augment will be equal to the phase angle phi. Fine. So how to find augment of a complex number, that I was showing. Let's suppose this is the complex plane. This is the complex plane, and you have this complex number is equal to, right here, suppose you have the complex number that g iota omega is equal to real part plus imaginary part. According to that, you can locate your complex number. Suppose your complex number is here, right, and this is the angle. This angle is theta. Your complex number is z1. Right? So if your complex number lies in the first quadrant and this angle is theta, how you find theta? Theta can be found as tan inverse modulus of imaginary part by real part. Tan inverse y by x. So imaginary part by, right here modulus, and first find theta. Now after that, you have this location. Suppose your complex number lies in the second quadrant, then this is the theta. It is not augment, it is theta. Theta is just the angle. Your complex number lies in the Z2, you can say, Z3 in the third quadrant. This is the theta. Your complex number lies in the fourth quadrant, Z4. This is the theta. Okay, this is not augment, this is the theta. Now theta can be calculated as tan inverse modulus of imaginary by real. Now what is the augment? So augment of Z1. Z1 is the complex number which is lying in the first quadrant. So for Z1, what is the definition of augment? Augment is the angle which the complex number makes with the positive direction of x-axis. This is the positive direction of x-axis and this angle is theta also. So augment of Z1 is equal to phi is equal to theta in this case, for the first case. In the second case, augment of Z1 I have to find. So first of all, I'll find theta from here. Now you see, where is the augment? Augment is actually this angle, but you know theta. So how I'll write? This is pi, anti-clockwise direction is positive, clockwise is negative. Pi minus theta. I have to report actually this angle. I want this angle, right? This is called the augment of Z2. This, okay. So this is theta. So this entire angle is phi and phi minus theta. Entire angle is integral. Okay, this integral is pi minus this angle which is theta. That becomes augment of Z1. Now for augment of Z3, first of all, we have to find theta by this formula. And augment of Z3, which is also equal to phi. This is also equal to phi for Z1. This is also equal to phi for Z3. How to report for Z3? See, आपने augment के लिए एक principle पढ़ा होगा that augment of a complex number should always be reported between pi and minus pi. The principal value of the augment it is called. So, actually see what happens that this angle I should report. But if I report this angle, it will be more than pi. And I can't have a value of augment more than pi. So, I'll report this angle. This angle will be the augment for Z3. अगर आप इस angle को augment बनाते हैं, this is the augment, right? How to report this angle? What is this entire angle? minus pi, then plus theta, minus pi plus theta. It's all about the directions, is equal to minus pi plus theta. Similarly, argument of Z4, in Z4 also I can't report this entire angle, it will be more than pi, so I'll report this angle. Now what is this angle? Minus theta. Argument of Z4 is equal to phi is equal to minus theta. This is how you report the argument of a complex number. Now the thing is, when you write the amplitude, this modulus, the modulus will be equal to amplitude ratio. And when you write the argument will be equal to the phase angle. So without finding yt, without finding the response, you can find the amplitude ratio. What is amplitude ratio? Amplitude ratio is basically the ratio of input amplitude and output amplitude. It is output amplitude divided by input amplitude. Okay, you know that both input and output are sinusoidal, then only I can talk about amplitude. Amplitude हमेशा sinusoidal में ही होगा, normal और किसी function में amplitude नहीं होगा. So amplitude ratio is output amplitude divided by input amplitude. So what you can do, either you can find the response yt. Once you find the response yt, you can convert it into sinusoidal form, then write amplitude, then divide it by a, then only you will get amplitude ratio. So to avoid all those efforts, we have this method of finding AR and phi, right? You may ask, sir, why we are finding AR and phi? You'll come to know later, don't worry. So please, इसमें अगर आपको कोई confusion है, go through this in detail, that how to find argument of a complex number. The argument will be equal to phi and the modulus will be equal to amplitude ratio, right? So argument is equal to phase angle, modulus is equal to amplitude ratio. Now, do you remember some properties of argument and argument and modulus? There are some properties, standard properties of modulus, standard properties of arguments. Because modulus is equal to amplitude ratio and argument is equal to phase angle, so the property of modulus is also applicable to the property of amplitude ratio, the property of argument is also applicable to property of this phase angle, right? So whenever you have a transfer function, it can be for a controller, can be for a valve, can be for anything. I mean, right now let's talk about the individual components. It can be a controller, can be a process, can be final control element, can be disturbance, can be measuring element, right? Can be the set point transfer function, anything. You have the open transfer function of that particular component, put s is equal to iota omega, make the complex number, find modulus, modulus will be amplitude ratio. Find argument, argument will be phase angle. But the question arises, sir, now what to do if I have the entire system, how to find the amplitude ratio or phi of that? So there I'm going to use, again I'll be using the same method, but there I'm going to use the property of modulus and the property of arguments. Okay, what is the property of modulus and what is the property of argument? Let's see. So suppose that you know that there is a transfer function which can be considered as multiplication or division of two or more transfer function. What I'm going to discuss now, that how to find AR and phi of a transfer function which is not consist of just individual component, but their combinations. So suppose a transfer function G open S is equal to, can be written as multiplication of G1S. G1S is some transfer function for which amplitude ratio and phi is already known. G2S and G3S. I'll take example for all of them. Don't worry. Dekho, here still it is open transfer function. Fine. And what is G1S? G1S is the transfer function of some component for which AR and phi is already known. G2S is the transfer function of some other component for which AR and phi is already known. G3 is the transfer function of some other component for which AR and phi is already known. Now, what are the properties of modulus? We know that modulus of multiplication of 2 or 3 complex number is equal to, fine. Similarly, modulus of Z1 by Z2 is equal to modulus of Z1 by modulus of Z2. Correct? Two important properties of modulus. Similarly, this is not valid for addition and subtraction, please note. Similarly, argument of multiplication of two complex numbers is equal to argument of Z1 plus argument of Z2. Correct? and argument of division of two complex number z1, z2 is equal to argument of z1 minus argument of z2. Correct? These are some basic properties of modulus and argument. There are many more properties as well. Let us not discuss all of them because we are not discussing complex number here. We are discussing this, the amplitude ratio and phi, how to find amplitude ratio. Now, suppose I want to find the amplitude ratio of this transfer function G open S. Okay. You have observed here that in this chapter of frequency response analysis, I'm only using open transfer function. So that is important. That is important that for solving or for finding the stability by this method, abhi to stability ki baat kar nahi rahe. Right now we are only discussing how to find AR and phi. We only use open transfer functions. Okay. So argument of Z1 and Z2, Z1 by Z2 can be written as argument of Z1 minus argument of Z2. Now suppose I want to find the amplitude ratio of this transfer function. How I'm going to write? Amplitude ratio of this entire transfer function means equal to modulus of G open S. Fine. And what is G open S? G open S is made up of these individual transfer function. So I'm going to use that property here, that it can be written as amplitude ratio of 1 means G1 ka amplitude ratio multiplied by amplitude ratio of G2 divided by amplitude ratio of G3, right? Provided you know the amplitude ratio of this individual transfer function. It means if you have a combined transfer function, then you must first check that how you can write that transfer function as a multiplication and division of some transfer function for which AR and phi is already known to me. Okay, so this is how I can find the amplitude ratio of this overall transfer function. Similarly, phi, I can write here AR overall. Okay, AR overall. Similarly, phi of overall system is equal to argument of this G open S. And how to find argument of G open S, which is made up of these complex number? It is argument of G1, right, or Z1, which is phi 1, okay, argument of G1, so G1 plus argument of G2 when you write these in the form of complex number, plus, plus it is minus, minus argument of G3. Means I can write this as phi 1 plus phi 2 minus phi 3, right? This is phi overall. So phi overall is founded by algebraic addition of individual phi, and AR overall is founded by this multiplication of the individual amplitude ratio or division of the this ratio. Means AR overall is the multiplication of individual amplitude ratio, and phi overall is the addition, algebraic addition of course, of individual phi's. Now the thing is, you must break your overall transfer function in that way so that you know the individual values. Right. So this property we will use to find the AR and phi of a transfer function which is kind of complex, which is kind of made by multiplying and dividing some individual transfer functions. So you saw that no need to write ys, then take Laplace inverse, then convert it into some r sin omega t plus psi. Without doing all those things, still I'm able to find AR, I'm able to find phi. And also if the complex number is or the transfer function is like a complex transfer function by multiplication division, it is made complex by multiplying and dividing, still you can find the values of AR and phi. So सबसे पहले देखो, we are actually doing stability analysis. I told you a method which was Routh method, which is simple to solve. Okay, but the thing is, this is one more method of checking the stability, but we have not yet discussed about stability. अभी stability की बात कर ही नहीं रहे, because in this method, for finding stability, we should first know about AR and phi. If you know AR and phi clearly, then you can find, okay, whether the system is stable or not. So I'll give you the criteria later. But first of all, it is important to know AR and phi. I hope you have noted down. If not, then pause and note. Okay. Now let us try to find AR and phi for some simple transfer function which we mostly encounter. Okay. So what you have to do, put S is equal to iota omega, find the amplitude ratio by taking modulus, and find the argument phi by taking argument. First of all, most common first order system. First order system. Can you tell me what is the open transfer function? GP open Don't write 1 plus. I'm not talking about open loop transfer function or the closed loop transfer function. I'm just talking about the transfer function of first order system. GP open is Kp by tau p is plus 1. What I have to do? Put S is equal to iota omega. Put S. I hope you understand the basic properties of iota. S is equal to iota omega. So G of iota omega becomes Kp by tau p iota omega plus 1. You know, whenever iota is in denominator like that, you try to rationalize this to convert it into standard form of tau p iota omega. ऐसे करते हैं ना? We multiply and divide by the conjugate and convert it. What is the next step? I want to convert it into standard form of a complex number. So this is how we do. This becomes Kp into, or let us write like this, Kp minus Kp plus iota into minus tau p omega. Is it right? Yeah. And then divided by a minus b, a plus b. So a square minus b square. What is minus b square? Tau p square omega square. Right? And iota square. That becomes plus. So 1 plus tau p square omega square. Now I can write this equation as Kp by 1 plus tau p square omega square plus iota into minus tau p omega divided by same 1 plus tau p square omega square. So that was my second step, that I convert this complex number into the standard form. I converted in the standard form. Now how to find amplitude ratio? Take modulus. How to find phi? पहले phi find कर लेते हैं. Phi of first order system is equal to argument. And how to find argument? See, how to find argument? Argument, first of all, you write theta, right? You find theta. In which quadrant it lies? X is positive, Y is negative. X is positive, Y is negative. Means it is in the fourth quadrant and their argument is equal to minus theta. And what is theta? So phi is equal to minus tan inverse Y by X. What is imaginary part? Modulus of that. So ये minus और minus दो बार मत लगा देना. Modulus of this is tau p omega. Denominator will be cancelled. Right. Okay, tan inverse Y by X. Huh? Now what is X? Tan inverse tau p omega. There is some, okay, there must be Kp also. This must be there. Kp is also there. Kp will be cancelled and minus tan inverse tau p omega. That is argument, and argument is equal to phi. Amplitude ratio equal to modulus, and modulus is equal to square root of real part plus imaginary part. Kp by 1 plus tau p square omega square का whole square plus, I hope it is visible, plus imaginary part square. So that is minus tau p omega Kp 1 plus tau p square omega square whole square. Real part square, imaginary part square. Okay? What can be taken out? 1 plus tau p square whole square, tau p square omega square whole square can be taken out and it will become 1 plus tau p square omega square. What else? Kp square can be taken out. Okay. In fact, in the numerator also there will be 1 plus tau p square omega square. Okay, and that will be cancelled here, so there will be square root. I hope you remember that this was the amplitude ratio for first order system when we discussed the response of sinusoidal input. The same amplitude ratio, the same phi I am getting here. So you will get the same answers. And this is the process for first order system. What else? Second order system. Now do it by yourself. P controller. Just P controller. Nothing else. Just P controller. So what is first of all GC open? You know the transfer function of P controller? Kc. If Kc is the transfer function, put S is equal to iota omega. Where is S? S is not there. So it is a purely real number. For purely real number, if I want, this is the, see, real number are also complex number, okay? Complex number, real number, then there are various divisions in the number system. So real number and imaginary number. Purely imaginary, purely real are kind of complex number, okay? So here it is a purely real number. You know that for purely real number, argument is 0 always, because pure real number lies on the positive x-axis. Assume that Kc is positive. Kc is positive. The pure real number lies on the positive x-axis and hence angle made is 0. अगर आप वैसे नहीं करना चाहते, then find argument, which is phi is equal to tan inverse y. What is y? 0. Okay. what is amplitude ratio? Square of real part plus imaginary part. Correct? Very quickly, Kc and 0. No need to do anything else. P controller is done. Third, PI controller. Do it by yourself. Quick. PI controller. Fourth, PD controller. Do it. What is the amplitude ratio and phi for PI controller and PD controller? Once you are done with PI and PD controller, then we can talk about PID controller. We can talk about pure dead time system. We can talk about pure integrator process, pure capacitive system, purely capacitive. And what else? Then we can talk about a second order system. And these are the basics. If we combine all of them in a particular way, then of course I told you the methods. Okay, so do these things. Let me erase this first order system and P controller so that I can make space for others. So very quickly you should be able to find AR and phi. So why we are doing all this? So that I can tell you one more stability criteria. But understanding AR and phi is not only sufficient to understand that stability criteria. What is required is the understanding of Bode plots also. So first of all, let us do this. Then we can shift to the Bode plot. PI controller. What is the transfer function? GC open. GC open is Kc into 1 plus 1 by tau is. Okay, that is GC open. Put S is equal to iota omega. Do the things. Put S is equal to iota omega. Write this in the form of a complex number. So in that case, G of iota omega will be, I think it will take some space here. That is third. Okay. आप लोग कर लो, है ना? So G of iota omega is equal to Kc 1 plus 1 by iota omega, first of all, tau I into iota omega. So that becomes Kc into tau I into omega into iota plus Kc by tau I iota omega. LCM सही लिया है ना? Tau I iota omega plus 1. I is not the subscript, remember. Okay, fine. Now what to do? We have done these things in our high school. Multiply and divide by iota. So it becomes iota square minus 1. So minus Kc tau I omega, right? Plus Kc iota. Okay? Divided by iota square minus 1. So minus tau I omega. If I want to convert this into real plus imaginary part, this is Kc, that's just Kc here. Kc minus Kc by tau I omega into iota. ऐसा क्या? आप Kc को मल्टीप्लाई करके iota आप वैसे भी कर सकते हैं. That is doesn't matter, है ना? There are various ways of doing the same thing. This is a standard form of a complex number. Now what is phi? First of all, check in which quadrant it lies. Positive real part, x is positive, y is negative. So fourth quadrant, so it should be negative of theta. And what is theta? Tan inverse of modulus of y by x. What is tan inverse of y by x? Modulus. So minus sign won't be there. Kc will be cancelled. 1 by tau I omega minus tan inverse 1 by tau I omega. Is it okay? Yes, it is. So that is phi. And that is equal to, that is argument which is equal to phi. Now what is amplitude ratio? Square root of this square plus this square. Square root of real part square, Kc square plus imaginary part square. In imaginary part, don't consider iota. Even if you consider, there will be problem because iota square is minus 1. Don't consider that. So imaginary part is only this, minus Kc by tau I omega. So that becomes Kc square by tau I square omega square. Then Kc can be taken out and AR will be equal to, these are very important values, Kc into root of 1 plus 1 by tau I. Kc, it is square, a square plus b square. So Kc can be taken out 1 by 1 plus tau I square omega square. Is it okay? Yeah. 1 plus 1 by tau I square omega square. That is the AR for PI controller. Do it the same for PD controller and then for PID controller. Kc into Okay, fine. Fourth one is PD controller. So for PD controller, what is GC open? GC open is equal to, what is the transfer function of PD controller? Kc into 1 plus tau ds. Okay, Kc into 1 plus tau ds, put S is equal to iota omega. So that becomes G of iota omega is equal to Kc 1 plus tau d iota omega. Very simple to write in the form of real and complex part, imaginary part, plus iota into Kc into tau d omega. Now it's very simple. What is phi? It is in the first quadrant, so phi will be equal to theta, and theta is tan inverse modulus of imaginary by this, so that becomes tau d omega. What is AR? AR is equal to modulus. Modulus is equal to square root of Kc square plus Kc square tau d square omega square. So that becomes Kc into 1 plus tau d square omega square. Done. Fifth, PID controller. Do it by yourself first. Do you remember the transfer function? PID controller. What is GC open? GC open is equal to, what was the transfer function? Yeah, Kc into 1 plus 1 by tau y omega plus tau d omega. Right. Now put, this is tau ds. Tau ds S. Okay. Put S is equal to iota omega. Try to write in the standard form. Let's see what result we are getting, what amplitude ratio and phase angle we are getting. So I think in this one, at least I have done a lot of calculation in this one. Please excuse me, you can do this calculation on your own. Put S is equal to iota omega, convert this into the standard form of a complex number. So phi you will be getting as tan inverse tau d omega minus 1 by tau y omega, right? So that is the phi of PID controller, and AR will be equal to Kc multiplied by 1 minus, okay, 1, yeah, that is, what is the AR of PI controller? Kc into 1 plus 1 by tau y square omega square. So it will be 1 plus tau d omega minus 1 by tau y omega whole square, right? Let us do this. Let us do this, whether I am getting this or not. Let us put S is equal to iota omega. This was the fifth one. It is almost done. So let us solve this one. And thereafter, there are only two systems left. Pure gain element I already did. For P controller is the example of pure gain element. I already found. So what is left after PID is pure dead time and purely capacitive. That's it. So 7 and 1 will be the, that is a kind of example of second order system. Only 1 is sufficient and 7 basics are sufficient. So tau d omega, let us put S is equal to iota omega. Let's see what we are getting. Yeah, you can verify this also. G of iota omega is equal to Kc into 1 plus 1 by tau I iota omega plus tau d iota omega. Then what we have to do? We have to multiply and divide and convert it into standard form. Let's see what we are getting here. Let us do this here only. कोई फर्क नहीं पड़ेगा ना? Multiply and divide this by iota. It is okay. So this becomes 1 plus iota by minus tau I omega plus tau d iota omega. Let's convert this into the standard and real part, real and imaginary part. Sorry, Kc 1 plus iota into tau d omega minus 1 by tau I omega. Simple, है ना? What else? You can see here only. Phi will be tan inverse. In which quadrant it lies? In which quadrant? 1 plus this. It lies in, we don't know. Actually, we don't know in which quadrant it lies because it depends upon the magnitude of tau d and tau I. So let us assume that it is in the first quadrant accordingly, or let us just write tan inverse of this by this, है ना? This part, imaginary part by real part. So Kc will be cancelled and tan inverse of tau d omega minus 1 by tau I omega. Now the thing is, this phi will be, it will be negative or a positive, depends upon the value of tau d and tau I. The magnitude of which derivative action is more or integral action is more. All those things are here also. They are obviously you can observe whatever we have discussed about these controllers. Whether they provide lead, they provide lag. You can see the nature of phi. In first order system, phi is negative. And I told you that, see, first order system, Okay, I'll make a table for you. Don't worry. 6. बहुत सारी चीजें will get confused here. Okay, AR is still remaining. AR. I solved it for AR only. So AR is square root of real part square, imaginary part square. It seems I wrote the correct formula. So Kc will be taken out. Kc will be taken out. Kc into real part square 1 plus imaginary part square, that is tau d omega minus 1 by tau I omega. Smart way of finding AR. It won't take much time, but suppose if you consider GC and you put y bar s is x bar s is equal to a sin omega t, find y bar s, take Laplace inverse, a lot of time consuming, and I'm sure that for this you will not be able to find this AR, because it is a lot of mathematics will be involved otherwise. 6th, so PID controller is done. Then purely capacitive process. Purely capacitive process means purely capacitive. Do you remember the transfer function of a purely capacitive process? G open S is equal to Kp by S. Fine. So G open S is equal to Kp by S. Put S is equal to iota omega. G of iota omega is equal to Kp by iota omega. The next thing, you multiply this by iota, divide this by iota. This becomes Kp iota by omega. Of course, it is a purely imaginary number and negative 2. So it is negative and purely, where it lies on the Argand plane? It lies somewhere here. If it lies here, what is the argument? Minus pi by 2. If you don't want to do it like this, then write the formula for argument. That is also going to give you the same answer. What is this angle? This is theta, and what is phi? Phi is equal to minus of theta. If it is in the 4th quadrant, then it will be minus pi by 2. Right? Aap kar lo tan inverse modulus of this by imagine, so you will be getting tan inverse of infinity, that is pi by 2, but because it is in the 4th quadrant, so minus pi by 2. Both ways you are going to get the same answer. AR, what is AR for this? Kp by omega, square root of Kp square and omega square, so that is Kp by omega. AR, correct? Purely capacitive, right? 7th one, likhte chalo. I'm not taking too much time for these things because ultimately you should be able to solve this. Itna karke dekhna, dekho, ratna nahi hamesha. You should do this also. You should have a practice in case you forgot in the examination. You have second option. Sometimes there is a confusion in these PI, PD, PID controllers. So just solve it. It will take hardly half minute. Not a problem. Half minute you can always spare in GATE exam. Not a problem. But if you are sparing those half minute, if you are using for a particular problem, make sure that there's no mistake in that. Okay. So that was 6th. 7th. Purely capacitive, pure dead time. Pure dead time. And for this, what is G open S? Do you remember the dead time transfer function? E raised to the power minus tau ds. Put S is equal to iota omega. अब आप बोलोगे सर इसका कैसे करेंगे? Either you know that e raised to power iota theta is equal to cos theta plus iota sin. Either you do that, but not to use those methods. Okay. You know that complex number is also expressed as Z is also expressed as R into E raised to the power iota into phi. Z is also complex number. This is called Euler form or polar form. Polar form of a complex number is polar or Euler? Sorry, Euler. Polar is, I think, R cos theta plus iota sin theta. Is Euler form of a complex number where R is the magnitude, where R is modulus of Z and phi is argument of Z. This is a way of writing complex number. So you can do one thing, that you can directly compare this. That if you write the Z is equal to e raised to the power, what is the value of R? R is 1. Put iota and rest minus tau d omega here. You can directly compare. Can I say that R is equal to 1? So R is modulus Z and modulus Z is amplitude ratio. So R is equal to 1. And can I say that the argument, whatever is, except iota, whatever is there, that is argument. So what is argument? Phi minus tau d omega. Ye bhi ho gaya. These are the 7 basic transfer functions. These are the 7 basic transfer functions, basic elements and their basic amplitude ratio and phi. If you know these 7 basic amplitude ratio and phi, you can calculate the AR and phi of any transfer function. I can give you 2 examples. I can give you 2 examples where by using these 2 ARs and phis, I can calculate the AR and phi of any transfer function by using the property of complex numbers, by using the property of modulus and argument, which I told you earlier. ठीक है? So I hope you have noted down. इसमें कोई दिक्कत तो नहीं है ना? इसमें कई बार दिक्कत हो जाती है students को. Actually, whenever I solve this problem in class, I first ask the student to solve it. नहीं कर पाते, because sometimes they don't remember that there is one more form of expressing the complex number like this. Okay, so okay, done. We are still doing the frequency response analysis. I have raised the topic, but still frequency response analysis. Okay, let me take 2 examples and let me show you how you find the AR and phi. And after that, AR and phi part is done. I'm taking one example of a second order process, right? One example of a second order process. You can consider this as 8th example. Suppose I have a second order process which is made by connecting 2 first order processes in series. So that is Kp by tau 1 s plus 1 and tau 2 s plus 1. And suppose I'm giving you one more little bit complex transfer function where the open transfer function is always open. For AR and phi, always open. Usually I don't write open, but I know otherwise you'll be asking me the same questions. So I'm writing open everywhere. Yaad ho jana chahiye. For this AR and phi, it is only open transfer functions. Okay, so suppose we have this Kc into, let me take numerical values. Na? We are fed up of these symbols. Let me take some numericals value. 2 into s plus 3 e raised to the power minus 0.5 s divided by what? ले लो इसको 2s plus 1, right? Whole square. You have to find AR and phi for this. Now these 2 are no need to remember them. Remember only 7. 7 AR and phi you should remember, learn. Okay, if you are not able to learn, then you should know S is at omega and how to deal with complex numbers. But you should learn at least those 7. You should learn. And here also I'll suggest you to make a table. See, whenever phi is negative, we say that there is a lag. When phi is positive, we say that there is a lead. For all these elements, I wrote phi. You compare all the phis. Can you see the phi of PD controller? That is tan inverse tau d omega. It is positive. Derivative action gives you a lead. You see the phi of PI controller, it is negative, minus tan inverse 1 by tau I omega, right? So that gives you a lag. See the phi of this first order system, tan inverse minus tan inverse tau p omega, lag. That is why a first order system is also called first order lag. एक क्वेश्चन है गेट में, पूछते बच्चे की बार सर व्हाट इज फर्स्ट ऑर्डर लैग, आपने तो पढ़ा नहीं. फर्स्ट ऑर्डर लैग इज नथिंग है. फर्स्ट ऑर्डर लैग इज फर्स्ट ऑर्डर सिस्टम व्हिच इज आल्सो कॉल्ड समटाइम्स एज एक्सपोनेंशियल ट्रांसफर लैग. लिख लेना सारे नाम. First order system is also sometimes referred to as first order lag or exponential transfer lag. Why lag? Because you saw the value of phi. Okay, so phi, all the things are justified or verified here. Whatever discussions we have made so far are verified here. Okay, let's talk about this. Now don't put s is equal to iota omega here. You have to put s is equal to iota omega only for the basic functions. Basic functions to kar liye. Now I have to find AR and phi for these combinations. For combination, don't put s is equal to iota omega. Again, even if you are using shortcut, it will become difficult to calculate. Just break it first. Break it as the multiplication of 2 first order systems. Itna kar sakte ho? Don't write Kp again. Kp will be only once. This is your GS. Fine. You have broken down this. Now, do you know the amplitude ratio of this one? Do you know the amplitude ratio of this one? Yeah, you know. So what is the AR overall? Don't put s is equal to iota omega, use the property. AR1 into AR2. What is this AR? I think I'm right. What is this AR? Done. Your AR part is done. Why to put s is equal to iota omega? Phi overall. The only thing you have to take care of is the proper breaking so that you know the AR phi of this, you know the AR phi of this. You can do that. Phi overall is individual sum. So there is no role of Kp in phi. Tan inverse minus tau 1 omega. I can also write minus here or here, you know, plus tan inverse minus tau 2 omega. Done. This is how you find AR overall and phi overall. Come here. Now, first of all, this one should be made like this. 2 by 2s plus 1. 1 by 2s plus 1. S plus 3. Can I write S plus 3 as tau ds plus 1? Can I write this as 3 S plus 3? Okay. Okay, I'll come to that. Don't worry. I'll do e raised power minus tau ds. This AR and phi, you know. AR and phi, you know. AR and phi, you know. S plus 3. What is S plus 3? S plus 3, we can consider. Don't compare this with a process. I don't know whether you will be able to do or not. But you know, S plus 3, this kind of transfer function is there for PD controller. So for PD controller, what I can do, that suppose you take 3 common. This will be S by 3 plus 1. Is it okay? Kc into tau ds plus 1. Done? Okay. Do you know the individual transfer functions here? Yes. So what is AR? Do you know the AR and phi of individual? Yes. AR is equal to multiplication of what? AR of this, that is 2 by root of 1 plus tau square omega square 4 omega square 1 by root of 1 plus 4 omega square. Constant, assume this is Kc. What is the AR of Kc? Kc, 3. Tau ds plus 1. Tau ds plus 1. Tau ds plus 1. What was the AR? 1 plus Kc into root of 1 plus tau d square omega square. I think I'm correct, na? Tau d square. What is tau d square? 1 by 9. 1 by 9 omega square. If I'm making any mistake, you can correct it in calculations. Not a big deal. And for this dead time system, what is the AR? 1. Done. This is the AR of the overall system. AR overall. Phi overall. Sometimes they write phi O. O for overall. What is the phi of this? Tan inverse minus 2 omega plus this. Tan inverse minus 2 omega plus Kc. What is the phi for Kc? 0. So 0 for this plus tau d omega. What is this? Tan inverse tau d. What is tau d? 1 by 3. So tan inverse omega by 3 plus this tau d omega. Minus tau d omega, I guess. It was minus tau d omega. That time is minus 0.5 omega. Now there is an issue here. There is an issue. You have written this, है ना? कई बार आप छोड़ देते हो. There is an issue. Actually, tau d is generally in times. Omega is a radian per time. Okay. So tau d omega has the units of radian. I think हमने इस पे पहले थोड़ा सा discuss किया. We have discussed it earlier. You know that tan inverse of something gives you answers in degrees. But this you have kept in radians. So you have to multiply this by 180 by pi to make it in degrees. In fact, you can do this in the calculation of phi for the pure dead time element also. For pure dead time, I told you that phi is equal to minus tau d omega. Okay, minus tau d omega. But please note that the units are in radians, so that you should be careful. If you are taking all of them in degrees, normally your calculator answer all of them in degrees unless you do some kind of settings. Your calculator always answer tan inverse of something in degrees. You can check. So this should also be in degrees. I have converted this in degrees. This is how you write the AR and phi for the overall system. Okay, so far you know that what is AR, what is phi, and how to calculate. Now what you have to do, make a table, write the AR and phi of those 7 transfer functions. You have seen that AR and phi is a function of omega. Hai? Everywhere AR is function of omega, phi is function of omega. If AR is constant, then of course that is also fine. It happens now if y is a function of x, but we sometimes write y is equal to 3. That is a constant. So this lecture was all about, in this frequency response analysis lecture, we just learned how to find AR and phi. There should be no confusion in finding AR and phi. Galti kahan hoti hai? You take closed loop transfer function for finding AR and phi. No. And the second thing is, sometimes for these kind of problems, you start putting s is equal to iota omega. Don't do that. S is equal to iota omega, I only told you for the 7 basic transfer function. After that, just use the property of modulus and the property of argument. So why we are discussing this? So that we can understand the Bode plots in a better way. Why we are discussing the Bode plots? So that we can understand the Bode stability criteria, which is the another stability criteria.